Okay, good morning guys. Padayon lang kita. Topic is about impulse and momentum. So, kita untat aton problem. So, number 7, force of a golf swing if a .0450 golf ball, so golf ball, initially at rest. Kita itong word nga at rest. So, iti ba iyo dana di pagit maara mag-analyze iton motion. So, kita ahiya. So, if initially at rest, so meaning your VO is equal to 0. Okay? Meaning, warahiya kiwa. So, if given a speed of 25 meters per second, so that would be V2. So, from 0 to 25 meters per second. So, lumaksiya, of course, may that acceleration. Basta sa dangat ng mga problem, may the acceleration. When a club strikes, if the club and ball are in contact for 2 milliseconds, what average force acts on the ball? So, average force, kay nga tanan nga force nga aada. Bangin to may friction, may magsiring. But anyway, bangin ito may friction, may normal. Anyway, all the force, kay bangin kasi ito um, may the angle, di ba? But in impulse and momentum, you can see nga, may da kita tugin solve nga problem, may diri ko diya na matter iton angle. Di ba? Ni mula kailangan, ni mo mga speed. Di ba? May da ko ginsolve to nga good example. Nga talaga, diri na matter imo angle, imo impulse and momentum. Na matter dito kinematics sa computation. But anyway, they do that, you have the same answer. But here, you can see that you only need a initial and final speed. And then you have your delta t. So, para na ato number 9 nga problem again solve. So, that is, if you want to compute that force, so, ano tutunahon nga solution by impulse and momentum manay. Because impulse and momentum man nga problem. So, you have this is how I picture it out. So, adin mo golf ball. So, pak, nag-swing hiya, amin imo 2 millisecond. Hilipot tayo itong duro nga time nga in contact animo, meaning hindi din ni abot nga di amo iton may the force. Okay? May the force di ka nganhi. Ngan that force, kung ano ito nga force, I mean net force, yung lang average force or summations of forces. Ito na nga tanan, nga mahataga iyahin velocity nga sugad. So amo itiya an imo force times time. That is your impulse. The impulse that was given to this ball, J. So that impulse is 4 F net, butangan tanan net or average. Average meaning wala na pakialam kung ano nga mga forces ada, but that is the summations of forces already. Kung may da ka air friction o may friction ka man ito dida, tikang didi ini dinhi, di ba? Ano pa pwede dida? May normal force ka dida kay bangin nakatagilid, di ba? Pag nakatagilid na nga nit imo force, basically may da na reaction nit imo normal force somewhat at imo weight. But again, 0.05 kay tadong nga pagtikang let's say ginswing hiya pa ka di waray hiya pa alam masyado iton angle because it is lumped as a net force which is F average, and then you have your delta T, your time. Ito nga contact which is 2 milliseconds. Okay? And then equal it to hiya to your change in momentum. That is P2 minus P1. So P1 is already ruled out as 0 because your reason for that because your first velocity is 0 at rest. Amo tiya, may mga reason ito kaya ano na 0 kita ha. So, actually, amo ito dapat dito tiyo pakusgon. Ano ba't karasingon ito at rest, ano ba't lo equilibrium, law of inertia, law of, di ba? Dynamics, how you apply your action-reaction forces. So, ganito tiya pag-analyze. So, you can rule out that this 25 meters per second, of course, will go to that momentum M times V2. And that is exactly your 25 meters per second. That is your V2. Your M is already given. Your delta T, delta time is given. So basically, you can rule out that force average would just be equal to mv2 all over delta T. So you can solve that one. M is 0.160. So that was given in the problem. That is 0.0450 kilogram. So 0.0450 kilogram, and then you have your velocity 2 which is 25 meters per second, and then you divide it by your time which is 2 times 10 to the negative 3. Again, that negative 3 is milli. seconds. Para malaksi na. Ano kita pag kinonvert, di ba? So, this is already mass second squared. Kaya diha ubos kasi. So, mass second times second. So, that is second squared. So, meaning this whole thing is already Newton. Which what we can expect from forces. So, that should be in Newton. So, we get a calculator. 0.0450 multiplied by 25 all over 2 exponent negative 3. And that would give us 563 in three significant figures. Unit is Newton. Okay, so that is your force. Solving it by kinematics, you only have to define the summations of force, average, is equal to ma. Okay? That summations of force, waray iba, kundi amo ito an imo force. Average. Okay, waray man iba nga force dida. I mean, may dagad, pero ginlampia as average force. So, F average would be equal to ma. So, ito yung problem, didit acceleration niya side. So, may dakat time, I think, amo lagap ang last nato yung gamit. We can have Vx is equal to Vox plus 80. So, and then it is ruled out that your Vox is 0. So, basically, your A is equal to Vx all over T. Okay? Then, substitute ka ni mo M, that is 0.0450 kilogram. Then, your acceleration is Vx all over T. So, that is your 25 meters per second all over your 2 times 10 to the negative 3 seconds. So, basically, you should have the same answer for this. That is 563 Newton average. So, lamp na ni mo mga resistance nga da, frictional force, normal force nga naka-incline, ani mo weight. Okay? Ano pa ba? Amo man naman tiya. Kita natot problem kung may pa. What average force acts on the ball is the effect of the ball's weight during the time of contact significant? Why or why not is the effect of the ball's weight during the time of contact significant? Is the effect with respect to the force average. Ball's weight, it has something to do with, yes, but kay nagbutang iya during the time of contact. Kung nilipot line during contact, ani mo kasi time, let's go back to our solution. So, ito ko nung, ini nga sa, meaning, iti mo iton, yes or no la, or iti mo iton concept, didit im summations of forces, nga ginlampiya. If an imo ginswing, usually an imo swing is x-axis la, diri masyado hiya patilt, 'di ba? Diri masyado patilt. Diri, because your summations of force would not have nothing to do with your normal force and your weight. Pero kung medyo naka-angle, you could just imagine, kung naka-angle niya, di ba? Kung naka-angle tiya, basically, diri tiya sugad kay taas nga swing. So, tami to nimo swing, ti ka ngada-ngada. And then, you could just imagine nga, hilipot la itong duro nga time. With respect kan imo, et imo kasi swing nga nakikita na, basta gini-swing iti mo golf club. Kung amo man ito kutob nga di nga swing, di ba? Kutob nga di nga swing, ngada, nga swing imo golf club, sa din imo ball. Let's say, adi din imo ball. Actually, ito imo swing talaga nga within contact iti imo kuan, which is 2 millisecond. Ito din lang ang part kutob nga da. 'Di ba? Kana swing pa mat aton golf club. So meaning iniya nga may gamay nga y, 'di ba? May gamay man ito nga y na. With respect to the 2 millisecond, waray na ito ya masyado effect. Okay? Because that y is first that y axis is so small compared to your whole swing, and then that delta time is so small. Gutela ito yung duro nga contact. And then firstly, mas more an imo kasi force ha imo x-axis la. So basically makaka-effect la kasi ito imo mass kung an imo pagbalbag ti ka nga ubos ti paigbaw. Di ba? Ta kay may ground man ito ubos. Di ka man ito mabalbag ti ka nga ubos. So basically, you could just imagine that force, that net force, guti ay ito imo y nga contribution. So basically, I could say, so ada kasi imo y an effect nimo mass, an massa nimo ball. So amo ti pakiana. So kon with respect to that during time nga guti tapos um gutelan imo y-axis at that time, yes, they are dependent to each other. I mean, that force dependent with respect to time, and that time is small. That force nga guti ay pa niya y-axis tapos guti ay pa niya time. So basically, I would say no, it won't affect that much. So that is the why or why not. So why not? Adi ako why not? Because again, with that explanation. Thank you guys for listening. So duha. So next would be potential energy kanang pisa or potential energy theorem or energy theorem somewhat. Thank you guys for listening.